Chemical periodicity continued. Looking at classification, as we said, there is the idea of metals versus nonmetals versus metalloids. There is also a classification by main group versus transition elements. Main group elements refer to those elements which are regular, predictable in their properties. They are groups 1A through 8A on the periodic table. The transition elements tend to be much less predictable. They occupy the middle portion of the periodic table in groups 1B through 10B. Main group elements, groups 1A through 8A, have regular and predictable characteristics. If I go down the group of each of these groups, we'll find the properties are relatively consistent moving down the group. There are four primary named groups that we deal with in the main group elements. They are group 1A, which we call the alkali metals. And these tend to form 1+ cations and are highly reactive, for example, the element sodium. Our group 2A elements, called alkaline earth metals, tend to form 2+ cations, and they are less reactive than the 1A elements, but they are still fairly reactive. An example of this would be the element calcium. Group 7A is called halogen. These tend to form 1- anions, and are highly reactive like group 1A. An example of halogen is fluorine. Group 8A are called the noble gases or the inert gases, and they tend to be unreactive. An example of this is neon, the gas which is used in electrical signage in things like Las Vegas. If I look at the periodic table, we have main group elements that are in the blue boxes. Your 1A elements and 2A elements are on the far left. Your group 3A through 8A are on the far right. So we find the first column is our alkali metals. The second column is our alkaline earth metals. The second to last column is the halogens, and the last column is the noble gases. We will see later on that the group number is very predictable in terms of electron configuration for the main group elements, and this is the reason why their properties tend to be as readily predictable as they are. Moving on to transition elements, groups 1B through 10B, we find that transition elements are often irregular in their characteristics, and usually this is because our electron state can be varied. We can change electron state much more than a main group element can. The transition elements we see lie here in the red boxes, the center of the table, and then the lanthanide and actinide series, which is at the bottom. Now, the lanthanide and actinide series, as you can see by the stars, actually belongs in the table where those stars are. So, for instance, lanthanum should go right after barium, number 57 right after number 56, Ba. And then it should end with ytterbium, which should then be right before lutetium. But the problem with inserting the lanthanide and actinide series into the point where it actually belongs is that then the bottom two rows of the main groups on groups 3A through 8A will be extended far past where they're supposed to be in terms of lining up with the rest of their group. So for the sake of continuity in our classification by main group, we leave the lanthanide-actinide series, or what we call the F transition elements, out of the main body of the periodic table.